Yeah, I hope all of you have played with the data and the code yesterday for the Titanic survival. Just as a recap, let's go to the beginning. So, yesterday we have seen how to do data preparation in Google Colab. We have got the data by using fetch OpenML. There are different ways to get the data into the Colab, but fetch OpenML is the easiest way, and we have used fetch OpenML. And then we have loaded the Titanic dataset into the Google Colab. We have inspected the missing values. We have selected the features for the model, the important columns. And then we have done the train test split. And after doing that, we have seen how to handle missing data and what are the different ways that there are to handle the missing data, what are different imputations we have, and when to use median or constants, and for categorical, what is most frequent and constant missing thing. And also we have proposed a pre-processing plan. For numeric path, we'll be using simple imputer and standard scaler, and categorical path, we have used simple imputer and one hot encoder. And for doing a pre-processing, we used something called pipelines yesterday. And we have created a neat pipeline definition of a function kind of thing, where numeric transformer has a separate pipeline and categorical transformer has a separate pipeline. So transformer, the word transformer is nothing but you transforming one kind of data to a different type. A different kind is nothing but transformer. And during our discussion yesterday, we have also come to see that we can only apply train. We can only apply dot fit to trains, and we should never ever apply dot fit to test data. And we have also discussed why you cannot apply dot fit to a test data. You should only apply dot fit to train data. And if transform, you can apply both on train data as well as for test data. Okay. Any doubts still here before moving forward to column transformer? I'll explain like what is column transfer and why we'll be using it. But before that, any doubts, anyone, till this moment? And I hope all of you had this link from yesterday. If not, I'll share it again. Ciao. Any doubts, anyone? Oh, wow. Okay. So yeah, let's start with combine with column transformer and on what it is. So now, since we have created a pipeline that can work on numerical data and categorical data, we need to apply the numerical pipeline to numerical columns and the categorical pipeline to categorical columns simultaneously. We have to do it simultaneously. Monish, why are we doing simultaneously, and why can't we do it step by step like how others do in other courses and all? In a real life situation, you will be working on again thousands of columns. If you become a very big ML engineer, right? Your data, your things will be very huge level. There, if you are doing data sequentially, if you are doing transformation sequentially, it takes lots of time for your data to perform an operation. But if you do it parallelly, right? If you do it simultaneously, right? The amount of time required for operation to perform reduces drastically. So that is the reason I'm going to teach you how to do it simultaneously, I mean parallelly. So multiple columns will be transformed at a time. And the technique that we are going to use is column transformer. What is column transformer here? So whatever the column that we have, like for example numeric features and categorical features, we will be submitting these features to the transformers. That's all. That is called column transformer. I'll show you first what is print. Where are our features? Numeric features, categorical features. Just to check if my runtime is connected properly, let me just stop this, because it seems like it's not connected. Yeah, now it's. So yeah, from the above you can see that numerical features are age and fair, categorical features are sex, embarked, and P class. That is what we have done in previous class. Now we will be giving these columns to the transformers. That's all. That is called column transformer. Whenever you are giving a column to a transformer to do particular operations, we call it column transformer. And how do we do it? From sklearn import column transformer preprocessor transformers equal to. We have two types. One is numerical type. Numerical transformer will be numerical features. Categorical will be categorical transformer and categorical features. So if you see, we have already created definition for numerical transformer and categorical transformer. We are just providing that here. Numerical transformer, categorical transformer, and we are giving what columns to be operated on. Numerical features and categorical features. Now whenever you use transformers, here on the top I've shown you, whenever you use a imputer or a transformer or anything, the first thing you have to do, you have to fit only on the training data to learn the patterns. So the same thing here, we do preprocessor dot fit. We fit it on our training data. Or else, let's say Monish, how will I know that I have to do fit before doing the transformers? Let's not do fit. Okay, let's not do fit. Let's directly do the transformer thing, like preprocessor dot transform. Extrain not preprocessed, it should be transformed. Okay, extrain transformed, preprocessor transform, no, preprocessor dot transform extrain and test transform preprocessor dot transform x test. Okay, now let's run it. Yeah. Okay, numerical transform is not defined. Okay, this is the classic error where, since we have closed the Google Colab yesterday and we are reopening it today, all the memory that is stored in the volatile is just gone. So what you have to do for this kind of like not defined, not found when you're doing fresh start in the next day is just you have to go to the top, click on this run all button, click this restart session and run all, restart session and run all, and wait for the entire collab to complete so that it will just remember all the data and it will pre-process them again. It will re-execute all the cells. Okay, but still we got, now I'll check why this happened. See, now we have a different error. It is called the not fitted error. Yesterday itself I said, what is not fitted error? Can someone tell me what to do in this situation after reading the error? Like yesterday we have discussed a lot of time on this. Like what is not fitted error and how to fix it. Any guess, anyone?
Do we have to just, once we run the pipeline, do we have to fit that on the test data?
Yes, exactly.
Okay.
So whenever you want to work on any kind of transformation in ML, remember that it is always better to do dot fit first. There will be few cases if the train data and test data are so matching, then this dot fit error won't be popping up, not fitted error. But in all the other case, there will be a not fitted error, and we have to resolve it. Thank you, Kamla. And to fix it, as Kamla said, we have to do a fit. That's all. If you just do a dot fit on the training data, automatically it will remember the pattern and then it will do the transformation. If I re-execute it now, it should work. Yeah, you see, original trained shape is 1047 and 5 columns. 5 means 5 columns. Transformer train shape is again 1047. I mean same rows, but this is something interesting here. The columns got increased. The columns got increased from 5 to 10. So what it says? We went from 5 columns to more. Why? Because one hot encoding expands categorical columns. If you remember, actually this is not required because xtest and xtrain will always have the same rows and same columns when expanding. So that's why you have 5 here. So yeah. So what happened is the sex column. Let me open whiteboard. Originally we had only 5 columns, but now there are 10 columns. How? I will tell you. Where is that columns? Yeah, these are our columns. Here, if you see 1, 2, 3, 4, 5. Totally, there are only 5 columns originally. But now, after doing the transformation, we have 10 columns in total. 10. We will see why there are total 10. What are the columns we have? Let's take sex first. So, the column sex usually had only two categories. One is male and the other is female. Okay. Now after transformation, what happens is this column sex will be divided into 2 columns. It will be divided into 2 columns. One is completely for male and the other is completely for female. So if you divide one column into 2, the same goes for embarked. Embarked has some around 4 columns, I guess 4 or 3, I'm not sure. So embarked has 3 columns, let's say. So embarked has 3 different types in it. Like C, Q, and S. So embarked is divided into three types now. One is C, Q, and S. So C is one column, Q is one column, S is one column. And the same goes for P class as well. P class. P class also has three categories, as I told, three categories. 1, 2, and 3. So it is divided into three columns, 1, 2, and 3. Now if you add them all, 1, 2, 3, 4, 5. No, there are somewhat 3 missing again. Where are the 3? Oh, okay. Sex male and P class. And also you have age and fair, right? Yeah, total 10. See, 1, 2, 3, 4, 5, 6, 7, 8. Now 8 columns in total, plus this age and fair. Age is 9, fair is 10. So totally it is 10 columns now. So categorical columns will be divided into multiple columns now. So that is why you see different. That is why you see increase in the column shape, column size. Now let me show you how it will be. Print x underscore train transformed dot head of, let's say, first 10 or first 5. Run it. Oh, it's converted to an numpy array, so you won't have dot head. Dot head, if you remember, it's only for pandas. So this won't show, but let me do it in this way. Yep. Yeah. But it's all now goes to. Let me show you on the sun data. Yeah, you can see here 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Total 10 values are here. This 0 is not down of this. This is to the right. I mean, the output is displayed in such way. But this is the just continuation of here. It comes to the right. But just since the place, because there is no place on the right, it just went bottom. Total, there are 10 columns now. So if you're wondering, Monish, what is this data and how this column will be divided? This sex is there, right? This will be divided into male and female. Okay?
Yes.
If a person individual is male, you will get 1 here and you will get 0 here. If for example A is male, 1 0. If for example B is female, you'll get 0 and 1. So I hope you got the point. So for an individual, if the individual is female, you'll get 1. If an individual is male, you'll get 1 to the male and 0 to the female. Just like binaries. How binaries work, it will be divided in such a way. And yesterday, our friend Komal asked one more question, like what happens if there is a third gender? Like let's say there is a trans. Then you will have another column here called a trans. And here you will have 0, 0. Let's say C is trans. Then you will have 0, 0, and 1. That is how categorical columns are divided after transformation. The same goes for embarked as well. You will have 3 columns, C, Q, and S. And whenever some individual is belonging to C, you will get 1, 0, and 0, something like that. That is the reason here you will see outputs in zeros and ones. Yeah, any doubts still here? Anyone, any doubts on how the column transformer worked, how it categorized the columns into different sections? Each categorical, again, if a particular column has 100 values, let's say there are 100 values. 100 different values, categorical values. Then after you apply the transformation, you will have 100 different columns, because each categorical value is a column after transformation. So that is why gender, sex will have 2 columns as of now, and P class will have 3. Embarked will also have 3, because there are 3 different categorical types in it, and each is denoted by zeros and ones, where 1 represents the presence, 0 represents the not presence.
Munish, I have a question.
Yeah.
Going back to a little bit where we handle the missing values, right, by using the imputer, simple imputer. I am trying to understand the step, like the next step after that, because we are setting up the processing for the numerical features and the category features. Are we repeating there anything? Because I see that, like, for the numerical transform, we are still using the strategy as median. Are we applying that entire, like, that I want all the things to be transformed for the numerical values, including age there, or is it?
Oh, okay. So for this line here, we are repeating, yes. Here
Okay.
I have shown you how to do it without a pipeline.
Okay.
This one. This is without pipeline, manual. This is with pipeline, automatic.
Gotcha. Yeah, that's what I just wanted to confirm if you were. Okay, thank you.
Yeah. So yeah, that is column transformer, where you, after creating the pipeline, you are giving the columns to that particular pipeline. And yeah, yes, you're right. I forgot to mention it yesterday. Yeah, whatever we have done here, it is for it is manually without using a pipeline, where if you have 100 columns, you will be using this code for 100 different columns. Each same code, 100 columns. But instead of doing that, we introduced something called a pipeline, where we can at a time do transformations on 100 columns at the same time parallelly, which saves a lot of time. Yeah, I forgot to mention this point yesterday. Okay, so yeah, and one more thing before moving forward, I want to say is the magic here is, after preprocessor.fit x of train, this line. After this line, the column transformer has memorized the median of age and fair from training data will automatically be memorized by the column transformer. That is the beauty of it, because here numerical features have 2 things, 2 columns. One is where is it? One is age and fair. So age will have a different median, fair will also have a different median while doing the imputation, simple imputation. But column transformer will automatically remember all of these things during this line, preprocessor.fit. That is how important preprocessor.fit of x of train is. If it is not there, the entire thing is going to break. The mean and standard deviation of age and fair from training data also gets remembered in this preprocessing. And the unique categories that you see in sex, embarked, and P class from training data will also be remembered in this preprocessor.fit of x train. That is how important it is. If you don't use it, the entire flow will not know what median to apply, what value to apply, where to apply, and all. So preprocessor.fit is the main line that remembers what to do. And when we call preprocessor.transform, it applies exactly the same learned values to the test data. No relearning, no leakage. If you use on X test, there will be a leakage problem. If you use it only on X train, there will be no leakage at all. So yeah, I'll also put a note here. Yeah. Okay. So we have completed 6A and 6B of steps. That is the pipeline, pre-processing pipelines. Okay. Now, we have a preprocessor that handles all our data cleaning. We have created the code in such a way that even if you have 1,000 columns, you have 10,000 columns, it doesn't matter to us now. Because we have created a pipeline, we have created a complete pre-processing. If you go back, if you go few steps back, this is what I am saying when I was first introduced you with when I was discussing about step 5 and step 6. Many engineers forget this step. Many engineers, they don't do pre-processing and they just go after the splitting directly to feature engineering and the training the model, which is a huge blunder mistake. Because the time when you get to work on very big data, very big projects, you will not understand how to scale the data, how to do the transformations on 1,000 columns at a time. So this step is very important. Again, I'm saying it is completely an optional step. Even if you use it, if you don't use it, the output will be same. But you have to put more efforts if you don't use it. If there are again 100 columns, you have to manually change 100 columns, transform 100 columns, and you have to write the code accordingly. And writing a simple function also will not work for 100 columns because functions run synchronously. One function gets executed, the output will be stored, then the next one runs. But column transformer here runs simultaneously. So here you will save a lot of O of time. The time complexity will be saved here. Okay, next the classification thing. So now we have a preprocessor that handles all our data cleaning. Now let's wrap it up together and with a model into a single end-to-end pipeline. The beauty of this pattern is that you only ever call two methods for the next coming thing. You'll only call two methods. One is CLF fit and the other is CLF predict. All pre-processing happens automatically inside with whatever the classification that I'm going to show now. You will be using only two methods because you already have done pre-processing. This becomes easier. And we will be using logistic regression. I forgot to mention. We will be using logistic regression for this particular use case. So let's import the algorithm. Import cascade on dot linear. Import logistic regression. Monesh, how do you know that you have to use logistic regression for this particular use case? Sorry, this is from what? It's correct, right? From SQL dot linear model. Yeah, it's right. So how do you know that we have to use only logistic regression? One way is to, when you're doing projects, like you're doing a number of projects, your mind automatically goes like which model you can use for, which algorithm to use for which use case and all. The another way for beginners is there is a chart. Let me see if I can find that. Yeah, you can use this chart as well, but I'm not looking for this. There is a better one. Yeah, I think you can use this as well. So you will see what type of data that you're handling. I'll also put it in our chat later. Yeah, I don't think I can put it here. Yeah, copy image address. Yeah. There are still better charts out there in internet. This is just an example I'm saying. So you will see, but every chart does the same thing. You will start with what kind of data you are working with. Whether your data is structured data or whether your data has like multiple features, low resolution images like image data, or you are having completely image, text, or audio kind of data. Based on the data, again, there will be further classifications. For structured data, simple ML algorithms can be performed, like linear regression, decision tree, and k-means clustering. And for low resolution images or multiple features, like the difference and lots of features, and you need to clustering. If you need to do any kind of clustering kind of use case, then you have ensemble methods like random forest, gradient boosting, XGBoost, dbscan. We will be covering this. In our next class is going to be on machine learning algorithms, models in machine learning and machine learning algorithms. So in the next class, we will be seeing what is supervised, unsupervised learning. In supervised learning, what are different types we have. In unsupervised learning, what are different types we have. What algorithm to use when. What are the benefits of one algorithm. What are the disadvantages of another algorithm. What are time complexities of each algorithm. When to use what, when to not use what. These all things will be covered in the next class. I'm just giving a gist of it now. So if you are working with very unstructured data like images, text, and audio, you have some advanced architectures like DNN, deep neural networks, transformers, and LLMs. So in this way, you can find out which algorithm to use for your particular use case. Now let's start going for our Titanic. So our Titanic data is a structured data. You all seen it. It has proper rows and columns. In structured data, you have some simple algorithms like linear regression, decision tree, and k-means clustering. Since our use case is just a simple prediction with all the data that is already present, my suggestion is to go to linear regression, because linear regression is a bit more simpler when compared to the rest. And our use case is also so simple. So let's don't overcomplicate the things and go with either linear regression or logistic regression. I'm picking logistic regression for now. But in the next class, you will get a better idea why I'm using what. For every algorithm you take, there is a pros and cons. For linear regression, there is a pros and cons. For logistic regression also, there is a pros and cons. You can see here. Linear regression, problem time, if it is a proper regression, you have to do linear regression on it. If your use case is a proper binary classification, for example, in our use case, whether the person is survived or not survived. A survived or not survived is a classical example of binary classification. Whether an email is spam or not, whether the person will buy this product or not, whether the person survived or not, whether a team will win the game or not. This binary classification, either only two outcomes, either winning or losing, either passing or failing. If your use case depends on only two things, only either this or that, and no chance of the third thing, then you use binary classification. And you will be using logistic regression or SVM, but I choose logistic regression for now. CLF pipeline. So Monish, what are you doing now? What is this classifier thing? I mean, what is this CLF thing? And what is this pipeline you're doing here? So usually, what others do is, after doing the pre-processing step, they do the classification again manually. But I don't want you to do anything manually. I want you to do everything with a pipeline, because with using pipeline, you're doing so, what do we say? You're optimizing the code in a different level, and you're optimizing the code to handle a lot of data. Even if there is thousands of columns and 10,000s of columns and 10,000s of rows, you're handling the data much more efficiently. Otherwise, here I can just say classifier logistic regression dot model dot fit, and we will be done. The model fitting will be done. But here I'm doing few extra steps just to make the code more optimized. So I have added pre-processing to be my first line of pipeline. After knowing that the pre-processor is done, then only we go to the classifier. and classifier is nothing but you're using your algorithm. Logistic regression, it shows yellow because here it shows yellow because wait. We did not give parameter, that is one thing, but why it says not defined? Okay, it's capital L. Logistic regression. Yes, it's gone. And you, even if you don't give a parameter, it would be okay. But whenever you use logistic regression, I have a habit of giving max iteration to be 300. Monish, what is this max iter equal to 300? In detail, I'll be discussing about this. What is this max iteration in the next class? But as a gist, if you don't give a value, and if during the model training, if something goes wrong, the iterations will be keep on going. There will be no end. If I give max iterations to be 300, maximum learning of that particular logistic regression that is being applied on the data will be only 300. Maximum iterations per column will be only 300. So here I'm limiting the usage of CPU. Now if I do print CLF, visual inspection of the pipelining structure. When pipeline a process plus more. Okay, see how the pipeline shows nested steps here. Preprocessor contains our contains our column transformer, which contains both sub pipelines. It looks complex. I understand. It looks, Monish, what are creating now? It looks complex, but it runs everything in one single line. Why? Monish, first of all, why are we learning again this? Again, I'm saying this is to optimize your code. And interviewers look for people who are very good at creating pipelines. If you've ever given interviews in ML engineer, at one point of time they'll ask you whether if you know how to build pipelines or not while creating ML. While writing the ML code, because the same thing can be done without pipelines as well. But companies love ML engineers who can create wonderful pipelines. The pipeline that I'm showing you now is a very simple pipeline. There are few pipelines in companies where there will be hundreds, 200s of steps. Just imagine how the data will be and how the code will look like. There will be hundreds and hundreds of steps for different pipelines. Each pipeline will have again 2 to 3 sub pipelines in them. So it looks complex, but this is what we have created for now. This step is already done. This step is already done on the top here. This step is already done. But this is a good way to do it. You always create a pipeline that should be so good that when the data gets entered into your pipeline, the entire pre-processing should complete. And when it goes to the classifier, the model also should be fitted. So everything in one single place. Now I can just delete it. I can just delete the top one. I'm not going to delete it because I'm sharing this with you. But now this code doesn't make sense anymore. You no need to do these transformations and all here. This code, the code that you see here. Because the entire code is going inside here. So you no need to do transform here. The transformers will be, if you already applied on the top, it's okay. Nothing's gonna change. If you do not apply on the top, it's gonna apply here. The transformations are gonna apply here in this pipeline. Since you already have done, it won't touch now. I mean, it understands that already the transformation is done, so it just skips this. Again, yeah, so this is done. Before moving forward, I just again want to talk about this logistic regression. Column transformers, I've explained to you, like what it does and all. But why logistic regression as a first model? Monish, you said you can also use SVM, you can also use linear regression, but why again you choose to only logistic regression for the first one? I'll tell you some pros of it. I really love logistic regression model a lot. I'll tell you the pros of it. It's interpretable. We can look at coefficients and understand what's driving the predictions and why it is driving the predictions in that manner. We can easily find that. And linear logistic regression is one of the fastest algorithm. Training takes, I think, only milliseconds of time, not even seconds, just milliseconds of time. So it's a very fast algorithm. And the third one is it's a solid baseline. Like anything more complex should beat this. This algorithm. So again, and this max iter 300 is like, it just means the optimization algorithm gets more iterations to converge. The default, if you don't enter anything, right, the default will be 100. Yeah, the default will be, I guess, 100. I don't remember properly. I think let's check once before saying. Logistic regression default max iter value. I vaguely remember it as 100, but I'm not sure. Okay, it is 100. So if you don't give anything, the logistic regression takes the max iteration to be 100, which is not so optimized. So 300 is a very good number to be optimized, and I usually use max iter to be 300. Not so bad, not so good. Okay. And yeah, once if you want to run, right, if you do clf.fit x of train and y of train, it runs all the pre-processing steps from the pipeline. If you do clf.predict, automatically it will do the model training and the prediction. That is what we are doing here. We are training the model now. So finally, we came to train the model. I told you, right, we will be using CLF to train, CLF predictor to actually train the model and predict. Now we will be doing that in the code wise. Now, finally, here we are training the model. Till now, we did not train the model. Till now, we did not even touch the model. Now is the time we will be training the model. CLF.fitter x train and y of train. Can any one of you, if anyone have any doubts till now, please let me know. We'll be training the model. And can anyone also tell me why for training the model, I told you CLF fit means training the model. It is going to send X train, Y train to pipeline. The pipeline is going to run and the logistic regression will be applied. But can you tell me why I am sending X train and Y train? Any guess, anyone? Why I'm sending X train and Y train? I said this in the first class, if I remember. I did not bring it up in the second class. First class, I explained you why training. When we are training the model, we'll be only sending the X train and Y train. Do anyone remember why? I also gave an example with a student and exam. Do anyone remember it? Like why we use X train and Y train and not X test and Y test and not X train and Y test? Why are we only giving X train and Y train to train the model? Any guess, anyone? You can try. It can be wrong. Not a problem. Okay, I'll help you out. If you remember, I gave an example about a student preparing for the exam. A student preparing for the exam. Extrain is your mock questions. Mock questions. Or not like mock questions also, just think of it like actual questions. Questions. And your Y train is your answers. Your important questions, and important answers. Important answers. Your capital X test and your small y test, they are your mock questions and your mock answers. So when a student is preparing for the exam, he will be studying important questions and important answers, right? He will not be studying the mock questions and mock answers. Mock questions and mock answers in the sense, before writing the actual exam, we will be writing a mock exam, right? In just to see how we are going to perform in the final exam. That is your mock questions and mock answers. Which mock answers we don't know yet. So we have to do the training in here. In real life also, we study in here. We study the important questions and we study the important answers. Predictions happen here. To check the accuracy of the predictions, it happens here. For training, this is what we have to use for fitting the model. For fitting the model, you have to use X-train and Y-train. To check the accuracy of the model, you have to use this one. Did you get it now? Why model, when fitting the model, we use X-train and Y-train, and why accuracy of the model we use X-test? Any doubts on that? Yeah, or if you have not understand, please let me know. I'll try to make it much more easier. No doubts, right? Okay. Okay, so now the moment we have been waiting to building toward training and evaluation of the model. This is where the child is going to learn. This is where the student is going to learn. This is where the model is going to actually learn. CLF.fit, just one line, CLF.fit. For evaluating, we will be using X-test. Import accuracy score, not accuracy score. Let me show you classification report. Classification report, and also let me introduce you something called confusion matrix. Yeah, and for YPRED, CLF.predict. And if it is for training, prediction is for predicting. And classification report on Y-test on YPRED. Here, classification report again. We discussed it before. Classification report is your mock test progress card. Mock test progress card. Your classification report is nothing but the Y-test that you have originally have and the YPRED. So here the teacher is going to correct your mock exam with the real answers and will get the marks. That is what classification report. We will give the original Y test and we give the predicted Y. confusion matrix and print overall accuracy round roughs clf.score. I'll tell you why I'm using round. clf.score, we have to give our x test and our y test, original y test, and I want the round with for 4 decimals. Usually more than 4 it won't be good at all. Up to 4 it will be good. Now let's execute it. So here we got our report. You see, the moment I have run this cell, the training got completed and the accuracy results also we have got. So this is our classification report of the model. Precision, recall, F1 score and support. These are important terminologies you have to learn, which I'll be talking later. Not right now. When talking about the models and the algorithms, why precision matters, why recall matters, I'll talk in detail. Actually, I think I'll give you a gist of it. I'll give you a gist of what all this. But in detail also I'll talk in the next class as well. And we got some confusion matrix. This is part where you will understand it better. The overall accuracy of this particular model is 0.8015, which means around 80%. 80.15% is the accuracy of this overall model. Now, you can improve this accuracy by using different ways, which is also called model tuning or fine tuning. Model fine tuning. Fine tuning is nothing but here you have given parameter to be 300, right? Let's change it to 500 and see what happens. Still it is same. So changing the parameters doesn't do anything. Maybe you can change the feature set. Maybe you can change the features to use something, some different columns, or else instead of using median, you can use mean. You can adjust different kind of things, and that is called fine tuning. Fine tuning is nothing but you tuning different parameters, different edge cases to make your model better. Now the accuracy is only 80%, which is, I would say, not too bad. It's okay. I would say it's just okay. Anything below 70 is bad. Anything below 70 is very bad. 80 is okay. 90 is good. Above 90, 95 are very good. 90, 97 is excellent. Anything bigger than 97, you have to just recheck the code.
Yeah, fine.
Okay, now let me give you a gist of precision, recall, and F1 score and support. I think I'll talk later. Support is nothing but the people who are not surveyed and people who are surveyed. If you combine them, you will get 262. Support is nothing but the total number of rows in the test data. The test data, if you see here, the total number of rows in the test data is 262. Out of the 262, 0 are the people who are not surveyed. That is 162 people are not surveyed. 1 means surveyed and 100 of them are surveyed. And that was the support here. Support tells you the ratio. Support just tells you the ratio, like how many have surveyed, how many have not surveyed, and all. If you add both of them, you will always give the total number of rows. 162 plus 100 is 262. Coming to precision, recall, and F1 score, let's talk in detail. Okay. So what is this precision? What is this precision? Out of all the passengers that we predicted survive, what fraction actually survived. Monesh, what it means? For example, I say during the mock exam, let's take the student and the teacher example. Okay, let me know if you are not understanding it. I'll try to make it easier. The mock exam is completed, not the main exam, the mock exam. You have given the mock exam, and the teacher asked you, hey, how many marks do you think you're gonna get? Okay, and you confidently said, I'm gonna get 80%. I'm gonna get 80% of marks. Then teacher started the correction of the mock exam, and you have scored only 60%. You have scored only the 60%. So you said 80%, but there it is only 60%, right? That is called precision. The difference is called precision. What percent you are right? So here you saying 80% and you getting only 60%. So you were around only 70% right. Or else let's take this. The teacher asked you, Maunesh, how many marks you're gonna get in the mock exam? And I confidently said I'm gonna get 90%. Let's say 90%. And the teacher started to evaluate the paper, and in reality I got 90% after the evaluation. So here my precision is 100%. Here my precision is 100% because whatever I said is the same thing there. So here, that is what precision means. Out of all the passengers that we predicted to be survived, what fraction actually did survive in reality? If this is 0.78, if it is, here the precision is 0.84 and it is for 0, right? 0 means the people who are not survived. So in the test data, it is something from the test data and from what we are predicted from the model, the percentage that the difference, the amount of rightness is 84%. So 84% of time that when we say someone survived, they actually survived. Sorry, 0 means not survived, right? 84% when we say someone is not survived, they are really not survived. That is what our model says. So 84%, there is a 84% chance that by using this model, when I say someone is not survived, 84% of chance that they will not survive. And Monish, what is this 0.74? Then 1 means, let's say, survived. There is a 74% of chance that 74% of time when I say someone is survived, they are actually survived. So that is the difference. And if it is 0.50, it is only 50% chance. So that is how precision works. Any doubts in precision before I go to recall? These again, please don't hesitate to ask me again and again. If you don't understand what is precision, recall and F1 score, forget that you will crack the interviews. You will not crack an interview without learning these three. That is how important these three are. These are very basics for any ML engineer. So yeah, if you have not understood, please let me know. Again, I'm repeating, precision is nothing but when you say something happens and that something really happens, that percentage, that how much right you are, is the precision. If I say 90% of time I will pass, and if I really get, if I get 90% of marks and if I really got 90% of marks, my precision is 100. If I say I will get 90% of marks and I got only 45 marks, my precision is 0.50 because it is only 50%. I reached only 50% of my goal. So that is precision. Out of all the passengers we predicted survive, what fraction actually did survive? If this is 0.84, we were right 84% of time when we say someone survived. Any doubts in precision? All good, right? Oh, length also necessary. Yeah. Okay. Next, going to recall. The next important metric that you have to understand is recall. Precision and recall, they look so similar, but there is a slight difference between them. Recall says that out of all the passengers who actually survived, what fraction did we currently identify? Here, how do I tell the difference? I'm just thinking, how do I tell? So here, okay. So precision works on predictions. Recall, on the other hand, works on actuality. Monish, what are you talking? What is this actuality and what is the difference between both of them, and why the values of precision and recall are so near, like 0.84 to 0.85? I think they will always be so near to each other. But why? What is this actuality, Monish? Again, taking the same example, for precision, what I said is, I'm predicting that I'll be getting 90% of the marks, and I got only 45% in reality when the lecturer corrected the exam. Here in recall, what happens is, I will do the correction, I will do some kind of correction before the teacher does. Again, I'm saying, before the teacher corrects my mock exam, I will correct it myself. Sometimes sometimes schools it happens, right? Before teacher actually correcting the paper, teacher will read out the answers and you will correct it for yourself. It happened to me. In some schools it happens. It usually happens for mock exams and these kind of stuff. Teacher reads out the answers and we will be correcting it by ourselves, and then we will give the paper back to the teacher and teacher corrects it one more time. So recall is that kind of thing. We will correct the paper once. So what recall says is, of all the passengers who actually survived, what fraction did we correctly identify? In the sense, here we are correcting the paper, or else I'll make it much more simpler. The teacher corrected the paper, okay? The teacher said, hey Monish, what the score is 80% or something, 84% something, some marks, okay? I don't believe in the teacher. I took the paper. After teacher giving me the paper, I started to reevaluate. We all did this, right? After we getting our assignment papers or exam papers, we start to recheck the scores. We start to count the marks, and if there is any counting mistake, or if there is any place where marks have to be given but the teacher is not given, we go back and we tell to the teacher, hey, I think there's a counting mistake and something, right? That procedure is called recall. That itself is called recall. You finding something that is not right and you going back and you checking it and telling is called recall. That name is called recall. And here recall mentions that of all the passengers who actually survived, what fraction did we correctly identify? If suppose it is 0.70, we caught 70% of the actual survivors. 30% of the people are also survived, but we did not catch them. We did not what do we say? Our model did not identify it properly. That is what recall says. Again, I'm saying, for let's say for question number 6, in your assessment for question number 6, your teacher has given you only 2 marks. Okay, but after you checking it, you said to teacher that, hey teacher, question 6 I have written the correct answer. I have to get 5 marks for it. The difference is there, right? The difference is the percentage of recall. Precision relies on predictions. Recall relies on actuality. Here, you have not looked at the paper and you are predicting you will get a percentage. Here, you looked at the paper and you know that something is wrong and something is changing, and you are doing a recall. So that is the difference between precision and recall. Precision, without even looking at the exam sheet, you are saying you are predicting you will get 84%, but in reality you did not get, and that difference is your precision value. In recall, your teacher already corrected the paper, you got the paper, you recorrected it, and you find some mistakes, you sent it back to the teacher. That is your recall. The difference between the actual and and what you have identified is the recall.
Absolutely.
So yeah, any doubts in precision or recall, please let me know. And yeah, please don't hesitate. These two are very important. F1 score is just the mean of these two. If you understood these two, F1 score is really simple. It's just the mean of precision and recall. Yeah, any doubt between precision and recall? All good, right? If any doubt, yeah, please let me know. Or else, if it is taking, I mean, if for now, if you are not sure whether you understood or not, also it's okay. And after the class, please again try to look at precision and recall. Try to even search in internet, and if you are still unable to understand or unable to grasp it correctly, just let me know. I'll bring this precision recall again in the next class.
So I have a question.
Yeah.
Like, we have to evaluate the model. Like, let's say, how are we using these values? Like, when to use which one? Or do we use all the three metrics? You see, when
Yes. Sorry.
no, did you understand my question? Like, when to use which one? Like, if I'm evaluating the model and I'm using these three values, can you walk us through how we can use these values, whether the model is right or wrong? Like, not right or wrong.
Yes. Okay, I'll tell about the trade-off.
Was
Do we go with like precision being higher, recall being lower is a better model, or like vice versa? How do we find a sweet spot, kind of,
did I
Actually, yeah,
try?
there is something called false positive, false negative, true positive, and true negative, which I'll be bringing up. In that, actually, let me tell you that here.
Wait.
Okay. True positive, true negative, false positive, false negative, I'll bring up in the next class. But as a gist, which you have to know, any model quality, let's say like this, model quality. How do you determine the model quality? If ideal perfect in the sense nothing can beat it, nothing can beat this model in the world. In the world, this will be the best model. If your model is so ideal and perfect, ideal perfect, if your model quality is ideal and perfect, then this is precision Always remember this table that I'm going to give now: precision, recall, and what's happening. Yeah. So if your model is ideal perfect, I mean it's the best model in the entire world. Even if after 1,000 years nothing can beat this model, then you'll have a precision to be 1.0 and recall to be 1.0, which means that whatever you have predicted and whatever the score you have got is exactly the same. The precision will be 1.0. It is exactly right, precise to the point. Whatever I have, if I say 84%, I'll exactly get 84% after teacher correcting my paper. If I say I will get 20%, I'll really get 20%. That is how precise I am. Your precision will be 1.0. What is this recall 1.0? If the teacher corrected the paper and the teacher gave me a score of 84%, and if I corrected the paper and if I also got 84%, then also the recall will be 1.0. I mean, there will be no difference at all. If there is no difference at all, your recall will be greater. Your greater will be 1.0. So in both the cases, your model is so perfect, nothing can beat it. Which means that what's happening in the model is there is zero false positive. Monish, what is false positive? False positive, false negative. This is a bit again a bit complex topic. I'll tell you in the next class, or if time permits, in today's class only I'll cover it. Zero false positive, and there will be zero false negative. Zero false positive and zero false negative. Yeah, your model will be too perfect. Precision should be 1.0, recall also should be 1.0. But whatever you predicted is what the marks given by the teacher, and whatever the marks given by the teacher, even after you correcting it, it will be the same marks. So there will be no differences in anywhere. Precision 1.0, recall 1.0. I'm just thinking whether if I have to teach you false positive, false negative right now.
It,
Okay, first I'll cover this and I'll go to false positive, false negative. If your model is good, which is what you have to aim for, you should not aim for your model to be ideal and perfect, it should be good. If your model is good, then precision will be greater than or equal to 0.85. 0.85 is enough. 0.85. And your recall also will be greater than or equal to 0.85, which means that when I say I will be getting marks of 90%, after teacher correcting it, I'll be getting around 80%. If I say 90%, I'll be getting around 80%. And if the teacher corrected the paper, and if it is 80, if I got marks of 80%, and if when I corrected the paper, maybe it has increased to 80% to 90%. That is also fine. So if your recall is 0. Greater than or equal to 0.85 and precision is greater than or equal to 0.85, then your model is said to be good. It is a good model. And what's happening here is there are few misses. Few misses. And few false alarms. False alarms. This is fine. Few misses and false alarms are totally fine. Because in a real world scenario, there will be mistakes. Without mistakes, you cannot do anything. So there will be few misses, few false alarms, and that is totally fine. When you say your model to be high precision but low recall, because there will be this kind of models also. Some models will be very high precision, but the recall will be very low. I'll tell you what happens when this high precision and low recall happens also. When high precision happens, right, your precision will be a very high value, like 70%, 80%, 82% and all. But your recall will be very low, like 20%, 10%, 30%, like that. When your precision is too high and your recall is low, that means that the model is cautious. Cautious. What is this cautious? Cautious means only predicts positive when very sure, but misses many real positives. In the sense, if I am sure that a person will survive, I will say that the person is survived. I'll say that the person is survived. But in reality, that person may have survived or not survived, we don't know. It's just my prediction. My prediction is good, but the actuality is bad. That is what I mean. Whatever the model is predicting is good. It predicts it. It is saying that the person is surviving. But in reality, it may not be the case. That is what recall low mean. So we have to be cautious with this kind of models. You cannot blindly believe this kind of models. Because this models is kind of a model where for let's say cancer treatment, this model will say for everyone that there is cancer. But in reality, that person may have cancer or may not have cancer. We are not sure. But the model will say it is the person is having cancer. So with these models, we have to be very cautious. You have to double check a lot of things. That is high precision and low recall. What is reverse of it? Low precision but high recall. What is this low precision and high recall? Here the precision will be low, but the recall will be high. In this scenario, the model catches everything. The model catches everything, but raises too many false alarms. So here what happens is, here it is too positive, a positive or negative, I said, right? Like here it says either it will say everyone will have cancer or it will say everyone will not have cancer. But in reality, it may not be the case. In low precision and high recall, what happens is it is not confident on anything. It is not confident on anything. For example, it will say it will say even if a person will have cancer, it can say it doesn't have cancer. If a person doesn't have cancer, it will, out of low confidence, it can say cancer. But whatever it says, sometimes it may be right. It might be actual thing. But this models also you cannot trust. This has trust issues. You cannot just trust this. This model, this low precision high recall also is not so trustable. High precision low recall also, you have to be cautious. Whatever it says, you can believe, but you have to double check. That is what high precision low recall says. Low precision high recall says, first of all, you should not trust it. So here you can trust it, but you have to double check. Here you should not even trust it. That is what the difference is. High precision low recall, low precision high recall means. And the last is poor. This is also low. This is also low. Model is both wrong. It will always be, most of the time it will be wrong, and also missing most of the real cases. Yeah. If you want, you can take a screenshot of it. I know the handwriting is very bad, but whenever your precision is high, I mean 1.0, 1.0, you can blindly trust the model, but no model as of now is 1.0 and 1.0. Because if you are able to create any model of 1.0, 1.0, then oh my god, you have created the perfect model in the world, and you can use it for that particular use case. But chances of getting that are very too low. But you can always aim for a good model. Good model where precision and recall will be greater than or equal to 0.85, that is 85%. Few misses, few alarms, which is how it should be. And yeah, and you can trust it. And this also applies to humans as well. I mean, just like to give a real life example, this also applies to humans. For example, let's say from your childhood, you're very perfect. You're from your childhood, you are very perfect in everything. You have never done a single mistake.
Won't catch that. Tell me again.
Sorry, it's yeah. Sorry, my bad. So from your childhood, you have never done any kind of mistake, and suddenly you have gone to. I mean, you are in a perfect environment, and you have never seen the society, and you are growing up so good. And suddenly, if you put your model in some third-party use case, right, your model breaks. If you are so perfect and if you are so habituated for a particular environment, then you suddenly go into the society, you find few things to be difficult. So that is the problem of ideal and perfect. It is so good. It is so good that you cannot use it for a different use case. But if you are good, where you have made some mistakes, you learn from it, you have understood few things and all, then you're set to be a good, because you can survive in any kind of environment. You put in bad society, you'll survive. You put in good society, you'll survive, because you already have experienced a lot of things. You have understood the misses, you have understood the false alarms, you have understood you have understood how to correct the mistakes, and you're going with it. You're going with the flow. The problem with you being a high precision and low recall is you're too confident on everything. You're too confident on everything. You're overconfident. But in reality, you're doing nothing. You without even giving the exam, you're saying that you will be getting passed. You will be getting the first rank. But in reality, you will fail. That is high precision and recall. You are so confident. But in reality, you are nothing. Low precision and high recall is you have no confidence at all. You have zero confidence. But in reality, you are doing everything extremely good. Like you are saying that you may fail the exam, but when you give the exam, you are getting the first mark. You're getting the top rank. That is the problem of low precision. With low precision, what happens is, even though you're giving your whatever you're doing gives good results, but no one is ready to trust you in the first place. Only when someone trusts you, they will be moving forward, right? No one will trust you. If you go to interview and if you're giving with low confidence, you're saying that once I get into the company, I will change the company and you'll be getting thousands of crores of profits. In reality, you may do it. In reality, you may have that skill in you. But if you're showing low confidence, right, the interviewer may not take you. That happens in low precision and high recall. In reality, you're good, but you're having low confidence. Poor is no confidence, you're not doing anything. That is poor. Any doubts on the model quality and how you determine the model? Or if anyone did not understand any of this, let me know. I'll try to make it much more simpler.
Thank you. No, I kind of fully understood now.
Yeah, thank you, Kamesh. Oh, it got disconnected. Let me rerun. And where did we stop? Yeah, precision completed, recall completed. F1 score. F1 score is nothing but the mean. The mean of the harmonic mean of precision and recall is nothing but your F1 score. The harmonic mean of precision and recall is nothing but your F1 score. It's just the mean of these two. If you take the mean of these two, you'll get this number. And and Monesh, when you say that F1 score is the mean of precision and recall, why we need F1 score, Monesh? So what happens is like when you're working with a lot of models, right? We don't have that much of time to check the precision and recall of every model and all. For example, if I'm using 10 models at a time to generate an output, okay? I don't do precision and recall on every model. I just do F1 score. That's it. I just do F1 score on every model. By looking at the F1 score, I can determine whether the model is good or bad. If the F1 score is high, the model is good. If the F1 score is low, the model is bad. That's as simple as that. So usually, I don't see precision and recall. I only see F1 score. Why? Because F1 score is nothing but the harmonical mean of precision and recall. So by just looking at F1 score, you can determine whether your model is what kind of model you have. Okay. And before the break, this thing is it's in my mind. I have to tell about false negative, false positive, and true negative. Otherwise, I may not be in peace by the end of this class because I talked about false positive and false negatives here. So let me quickly complete that topic since we started it. In ML, you have to know there is something called true, false, and this also applies to real life. I'll tell you how. False, true, false, positive, negative. Okay. Okay. Monesh, what is this? What is this true, false, positive, and negative? In ML, for every model that you take, there will be few things. One is true negative. One is true negative, true positive, false negative. Let's see what each one talks about for this particular model that we have created. First, let's talk about what is true positive. What is true positive? Here in the Titanic survival, what is the positive scenario? Can someone tell me what is the positive scenario in our Titanic model? Or in real life, if you're talking about Titanic prediction, as a human being, what is your positive thing? Whether a person is survived or not survived. What is your positive?
Person surviving.
Person survived, yes. If a person is survived, that as a human, that will be a positive survivability. It applies to anything in life and for any model as well. If you are taking for example, if a student is passed or failed, their past becomes positive, failed becomes negative. Okay, I'll write the survive here. Survive to be positive. Not survived is negative. And again, this is purely individual's thing. For example, if you are an insurance company, let's say, if you're, I'm sorry, but yeah, if you are an insurance company, for insurance companies, this may be reverse. For them, the positivity is a person, I think, in what scenario a person not being survived gives benefit? Okay, let's say the government said that for whoever survived, take a scenario, just a scenario. Whoever survived will get 1 crore rupees, and whoever not survived will get only 1,000 rupees. Again, this will never happen, but just take a scenario. You will get a gist of what I'm saying. You will get that thing. When the government says like this, right? The organization who have to give survivors crores of money, for them, not survive will be the positive, survive will be the negative. It's an individual's thing. You cannot argue. Like for every human, only survive is the part. You cannot argue like that. It's an individual's choice. So for every different model, ML engineer decides what is positive and what is negative. Or the business people decides what is positive and what is negative for any model, for any use case. Okay, just keep that in mind. So for our scenario, survive is positive, not survive is negative here. For general humans. Now, what true positive says that if the model identified that a person is survived and the person is actually survived, then we call it as true positive. Again, I'm saying when we call something is true positive is the predicted is also survival, the prediction is also positive, and the actual is also positive, then we call it as true positive. In the sense, the model predicted so and so, the model predicted Monish will survive the Titanic, and in reality if I survive, then we call it as true positive, because whatever we predicted, it happened. It is true positive. True positive. Remember, true positive, whatever you said, it will happen. It is true positive. Now come to true negative. The predicted is negative and the actual is also negative. Again, sorry for my passion. Actual also negative. Here what it says that the model predicted someone will not survive, and in reality also sadly they did not survive. So it is true negative. It is true only, but it is a negative aspect. This is true, it is a positive aspect. This is true, this is a negative aspect. That's all. When the model says it is predicted, the person is survived, he is survived. When the model says someone not survived, he or she did not survive. So that is the true scenarios. Now coming to false positive and false negative. Here, false positive, the prediction will be positive. Here the prediction will be positive. Prediction will be positive. But in actual reality, it is negative. Which says that the model said that someone will survive, but in reality, the person did not survive. Here, in false negative, the prediction is negative and the actual is positive. So here in this what it says that the model will say the person will not survive, but in reality he survived. So that is all the things you have in ML for model. True positive, false positive. True negative, false negative. Now I explained this right. First of all, if anyone have any doubts, please let me know on this. And what two things you have to follow? What two things your model have to follow? When do you say your model is good? On what conditions? Can anyone tell me? Your model is said to be good in which of these four? True positive, true negative, false positive, false negative. In which of these four your model is said to be good? And it is not a single answer, it is a multiple answer. Can anyone tell me where your model has to be placed?
You need to have a higher true positives.
Only true positives?
Not necessarily.
Then possibly
I'll give a hint also. You can pick two. But this is right. This is perfectly right. True positive is exactly correct. If your model has a very good true positive score, it is very good. There is one more also in these three. Take a guess. It may be right or wrong. Okay, I'll give you one more example. You will answer me. True. Again, this is one more example. True, false. This is for cancer. Okay, this is for cancer prediction. Let's do one more live here. Positive, negative. Cancer not there. Cancer no. Cancer. Now think and tell me where this is right. This is perfect. If your model has high true positive, that is correct. Again, I will repeat. You think and let me know. The model says that you have no cancer, and in reality also the person doesn't have any cancer. That is true positive. The model will say that you don't have cancer. I mean, the model will say that a person don't have cancer. Sorry. This is cancer, right? Negative aspect. So the model will say that the person has cancer, and in reality also they have cancer. That is true negative. False positive means the model will say the person doesn't have cancer, but in reality the person will have cancer. That is false positive. The model will say that in reality the person will have cancer. Here the model will say the person doesn't have cancer, but the person will have cancer. Now again think and tell me where I have to put the next tick to make my model the best model. Here or here?
I'll go with true negative.
Exactly, right. In both these aspects your model is correct, because that is correct, right? If the model predicts the person don't have cancer and the person in reality also don't have cancer, it is good model. It is correct. It is predicting perfectly. So the same for here also. If the model says the person is survived, he survived. If the model says the person will not survive, he did not survive. So in both the cases, the model is perfect. If you have good true positive and true negative, that's all. You're done. It is good. The model is good. If you are having false positive and false negative high, it is concerning. You have to do something with the model. Oh, yeah, we got the answer. So yeah, thank you, Gobla. Thank you, Lanta. So I also explained it true positive, true negative, false positive, and false negative. Yeah, if anyone any doubts, please let me know. Till here. This is the complete, actually I thought of covering it in the next class, but this is how the entire metric of model works. Precision, recall, accuracy, true positive, true negatives, false positive, false negatives. And this is nothing but your confusion matrix. You see this confusion matrix, right? 137, 27, 25, 73. So 137, let me get the right points.
Was very nice.
Confusion matrix, true, positive, negative. But I need a picture. Yeah, this is the table. Remember this table: TP, FN, FP, TN. True positive, false positive. True, false negative, true negative. Remember this table, because this matrix you see here, right? This matrix matches with this one. So you have to keep this in mind. Okay, always put this in mind. True positive, false negative. False positive, true negative. So here, whatever I have explained, I have used my own. So in reality, the table will look like, let's write here, TP, which is true positive, FN, which means false negative,
That's right.
FP, false positive, TN, true, FN, right? It should be, yeah, TN, true negative, true negative. So always make sure your diagonal is good. Your true positive should be good. Your true negative should be high. These two should be high always. Remember. So in the confusion matrix, if you see here, 137 is true positive, 73 is true negative, which is good model. That is why our accuracy is 80%. Otherwise, it would have been much lower. So yeah, if any doubts in precision, recall, F1 score, support, confusion matrix, true positive, true negative, false negative, please let me know before going for the break.
So that's right. So,
All good, right? Okay, then let's take a break, 20 minutes, and meet back after 20 minutes. Yeah, see you after the break then.
Right. Right. It's fine.
So yeah, welcome back after the break.
Use.
So now we have successfully evaluated the model. We have got the precision, recall, and F1, and we have seen what each does. We have also seen what is true positive, true negative, false positive, and false negative. Now, oops. Yeah. Now let's predict. Do a prediction for single passenger. This is one of my favorite part of every ML project is to making it feel real. Let's predict survival for a single passenger now. Think of this like the actual exam for the student.
Good. To us. I think.
Very- Let's take the first one.
Right.
Sample.2. You remember, right? Whenever I print numeric, I always change it to string. That's a habit of Wins.
Good.
Predicted, and the props will be clf dot predict
Prediction.
You may be thinking what is props. Props means probability. I mean the percentage. We will be getting it in percentage. So predicted will be this, and the probability percentage of it is CLF dot predict props proba, I guess. If it's wrong, I'll change it. Sample of 0. Print. Let's do format, or else just do this. New line. Predicted survival. Predicted. It's doing a prediction now. Oh,
So that.
actually, know what? Print.
Like this.
Yeah, this makes more sense. X of test is not defined. Okay, so here again the same issue happened. We went for a break and we came back, and the memory got erased. So what I do, I just do restart session and run all.
That's it. That's it.
So yeah. We have taken a one individual for one person. We have predicted only for one person, a female, and so probability of that particular individual not surviving is 0.46, and the probability of the individual surviving is 0.53. So yeah, we have created the model, and this is our prediction. Now let's create our custom passenger. Custom passenger in the mean, I mean, we giving our own data. Like we are giving our own data from outside, which is not there in the Excel sheet. Was it better to be a child in third class or an adult man in first class? That is what we wanted to check. Again, I'm repeating the question. We are trying to check, will it be better for survivability as a child in the third class, I mean in the third class of the ship, or as an adult man in the first class of the ship? So that is what we wanted to check. Or you can also simply check on the same conditions whether it is better to be a female or a male to survive. Or you can also check what my age could be to survive. You can with this model we can check all these kinds of scenarios. You can also create an app called Titanic Survivability, and you can ask the customers who are visiting your website to enter their details, and you can just give them whether they will be surviving Titanic or not. A fun project kind of thing. So now we will be giving our custom passenger data. Yeah, so this is my new passengers data, and CLF.predict my passenger. It's better to put it as the first data. You may have many. Also, we need the proba. Eight-year-old girl in third class of Titanic. Print predicted. Actually, we don't want to give the customers how much the percentages and all, right? So there is a neat technique to do this. F predicted to be survived when if
that
spread equals to 1, else we say did not survive. Okay, and now begin survival probability proba so T1 is to 0.2 decimal points, up to 2 decimal points is fine. First, let's run this and check. There is a number. Here somewhere it went wrong. Let me check. Let me reformat it properly. Yeah. So yeah, you can see here. So this is our new prediction from a data which we have taken from outside, and you can see that the 80-year-old girl, third class, is predicted to be survived. Probability of 69.70%. Now let's take the same code, copy it, paste it here, and instead of saying my passenger, I'll say adult man, and the age to be 35, E-class to be 1, embarked is C, sex is male, and now I do spread 2, proba 2, spread 2, proba 2, adult, and run it. And the adult man also, oh sorry, here I have to change 35-year-old man, first class. Yeah, so the 35-year-old man also has survived. So this is how you check the data which is coming from the outside. This is the new data that our model is working on to make the predictions. You can simply create a new website or anything like that, a fun game like called Titanic Survivor, and you can give the details, and the model will tell whether if the individual is survived or not. Simple. Any doubt still here? Anyone, any doubts in this moment? So successfully we have completed the project where we have took the Titanic data. From the Titanic data, we have cleaned the data, we have looked for the features, we have created the pipelines, and then we have trained the model, and after training the model, we found the accuracy of the model, and then we did the predictions on the model. This is the complete flow, And in this flow, you can put anything. You can put anything you like, and you will get the outputs. You can put instead of tightening data, you put education marks data, whether a student will pass or fail. Any binary classification use case can be solved by the code that we have here. Any kind of project can be made. Any doubts still here? Okay. So yeah, now we have built a working end-to-end model. It loads raw Titanic rows and cleans them, trains and predicts. The next natural question is, can we make it better? Monesh, can we make this model? That's where feature engineering comes in. That is where feature engineering comes in, or we can also call it as fine-tuning. These are the next steps after doing the project. Feature engineering is simply taking raw columns and turning them into more informative features for the model. The model is only as smart as the inputs you give it. That's what I said in the beginning. The more the better the quality of teaching that we give to a child, the child turns out to be the same. So that is where feature engineering comes in. The model also the same. The model is only as smart as the inputs you given. If you give right inputs, correct inputs, the output will be good. If the most important relationship in the data is not represented in your features, the model can't magically discover it. The model doesn't have any magical things to directly discover something. All the relationships, all the other things have to be mentioned in the model itself. If it is able to identify the relationship, it's no longer model, it becomes AI. If it got the consciousness to understand the model and the relationships, understand the relationship between the data, it is no longer a model, it becomes AI model, it becomes LLM. That is what I was saying in the beginning first class. A model is like a child which is not 5 years, which did not get the consciousness yet. Only if you say that she is your mother, then only the child will understand that the relationship between the mother, father, and all. Magically, it cannot get that until it gets the consciousness. So the same thing happens here as well. For Titanic specifically, think about the historically matter. Like children may have been prioritized when lifeboats were loaded. That is why the data says children have higher survivability. That is what I understood here. I don't think an 8-year-old girl who is sitting in a third class will have a survivability probability. I don't think so. Unless and until in real life scenario someone helped the girl. So we have to also take historically mattered real life scenarios also into considerations. Examples: children may have been prioritized lifeboats when they are loaded. Women were often given priority over men. Passengers class and fare reflects wealth and cabin location. Traveling alone versus with a large family could also matter, because if you're traveling alone, you can simply run here and there, you can get the lifeboat and you can just go away. But if you're traveling with a family, again, lot of decisions come into place. You have to find your family member, you have to get the family member. So the chances of survivability again changes there. So potential engineering features include each child, one. I mean, you have to put this kind of column. I'm not going to do it now here. I'm not going to put all the code here and all. These are all the things I'm saying that you have to consider. Here is the code and this will be the assignment for today. So what I'm saying is, you have to do a potential engineering features columns that include, you have to create a new column called each child. If each child is 1, then it is a child. If each child is 0, then it is not a child. You can simply say if age is less than 18, child. If age is greater than 18, not a child. Then you have to see family size. Already we have columns like SIBSP, that is the siblings, and the PARCH, which is the parents and child. By using that, and so SIBSP plus PARCH plus 1, that one is you. All of you you can do a sum and you can find the total family size. Total family size can be one more column. Is alone. If your family size is equal to 1, then you're traveling alone. So is alone can also be a column. Then finally title, extracted from the name of the column. Like for example, in the name of the column for the data, we have Mr., Mrs., Miss, Master, etc. and all. Instead of all of that, you can remove all of those things and you can get the actual name from the column. Maybe you can. Or else you can do also something like this. You can extract the titles from the name, like Mr., Mrs., Miss, Master and all. Because in Titanic era, people who are wealthy, they are called Mr. or Miss or something like that. People who are poor, they don't have these titles. So based on this title extraction also, you can get more details from the data. So today, we have implemented this so far. Now it's your call. If you want me to proceed, if you want me to put the code, I already have written the code for you. This code I have already prepared it for you. I thought of giving it as an assignment for the end of this week. So that Monday to Friday you will try it to put this in the Google Colab and you will come up with the outcomes. It's a very simple thing. All you have to do is copy this code and paste it here. I won't paste it, but you have to do it. Paste it here and run it. That's all. That is the only thing you have to do. And you will get the baseline accuracy and all. You can see that any change of accuracy and all. So what do you want me to do? Will you all try it or do you all want me to do it?
No, I feel like I want to try it.
Yeah, sure. Yeah. So this is one thing we can do to improve the model accuracy. So you're getting my gist, right? You also have to take a lot of things into consideration when doing ML. You can't just blindly rely on the data or the code. Because as I said, in a real life perspective, in a real life scenarios, when the ship is sinking, you have to think as if you are in that boat with them. Because children will be prioritized for the boat, women will be prioritized over the man. So you have to take this into consideration. Otherwise, you will simply say that an 80-year-old girl, third class, will survive. But in reality, I really doubt this. In reality, this will never happen until the girl gets some kind of help, an external help. So we can't rely totally on the code and the data itself. So yeah, this is one more thing. This is called feature engineering. Or else you can also say something like tuning the model or fine tuning. There is a whole book written on the top of feature engineering. There are a lot of things in feature engineering. And that requires a lot of domain knowledge. That is why you see, if you apply for some petroleum companies, right, as an ML engineer, and you and your friend, if you're applying for a petroleum company and you already have an experience with petroleum and your friend doesn't have an experience with petroleum, there are higher chances that you will be getting hired in the company. Because the people who hire you, they also look for your past experiences matches with the current experiences that you have. This usually happens in healthcare. People with healthcare domain are more preferably to get into ML healthcare domain jobs. Because they will understand the things behind the healthcare, like how the patient reacts to the things, how the doctors reacts to the patients, the timing that changes everything. So all of these things comes into consideration. And yeah. Coming to the pipelines that we have created from the code, everything we did today with Titanic is a template. Again, I'm saying the entire code on how I designed, the entire project on how I designed is to be a template. If I don't want it to be a template, I would have done few other things. But when I started this project in my mind, I want it to be a template and not a one-off project. So that you can take this structure and apply it to almost any tabular dataset you care about. It can be any tabular dataset. It can be COVID dataset, it can be cancer dataset, it can be health dataset. Any dataset you take, you can just apply this code and you will get the results. I'm sure I already tested it before putting it here. I tested it with Iris. I tested it with some volcano, whether the volcano will erupt or not erupt. So I tested on few other data that I have, and for all of them it worked fine. Only then I presented it to you. So it's the code that you have is a template. Here's a general thing that you can do. You load the data into pandas, you visually inspect it, you decide which columns to use, you split into train and split, you build a numerical and categorical pipelines, you combine them with a column transformer, you plug that into a pipeline with a model, you train, evaluate, iterate with feature engineering and with different models. That's all. All of your projects will be in the same structure. Yeah, and finally I want to tell you, use Google Colab with GPU. Whatever the code that we have run so far without using GPU also, it doesn't matter, because in the earlier beginning of the last session itself I told you, this particular code, what we are going to do is simple, the data is simple, so we are, even if you do runtime in CPU or GPU, it doesn't matter. But moving forward, in the coming classes, you will be working on some complex code and all. For that, if you are using CPU, it will take a lot of time for it to execute. So always suggestion is click, even if you need it or don't need it, click on runtime, change runtime type, and click on GPU. You no need to pay anything for it. It is completely free. So change it to GPU. That is one more thing I wanted to include. Yeah. Finally, you built a real ML project today. We got the data with fetch OpenML, and we loaded the real data into Colab using multiple methods. We inspected the structured data types, filtered, built numeric, combined them, trained them, making predictions, learned about something called feature engineering. Also, you can, my suggestion is after this class, when you have time, swap the models. Monish, what do you mean by swap the models, Monish? Here in the code, I have used logistic regression. Where it is? It's above this, right? Here. Instead of logistic regression, use random forest. Use something like random forest. Random forest also, I think it works good. Yeah, you can also try random forest classifier. Give it a try. That is what I wanted to say. Try different models. Don't trust on only the models I use. Try different algorithms and see if you are getting any good accuracies and all. There won't be much of code change also. Wherever logistic regression is there, you will be using random forest. Simple. And yeah, for homework, I already said. For homework, you will be doing the feature engineering. All you have to do is just copy the code and paste it. You will get the result. I have already given the code in the presentation, and I'll send the presentation to you. And pick it, and as an extension to that, pick any small Kaggle tabular data set. It can be customer churn, it can be loan data, it can be financial data, any data. Pick any small Kaggle tabular data set. Repeat the exact same pattern. Identify numeric categorical features, build pipelines, combine them with column transformer, train and evaluate the model. Add at least one engineered feature based on your common sense and your domain knowledge. Add any one feature, column based on your common sense and domain knowledge, and see if that helps. Monish, why are you telling me to do this kind of homework and all? If any of you feel in that way, if you do that even once on your own, if you try to do this kind of structure even once on your own, this pattern will become your muscle memory. That is what I'm trying to achieve with you all. You have to get this kind of muscle memory. Automatically, your brain should think on what features to select, on what data looks like, how the missing values are, what the imputation I have to use, how to train, how to split the data. Your mind should automatically think about all these things when you look at the data. And that happens only because of muscle memory when you do it. Then we move into more advanced topics in the coming classes. Like some of the topics that I'm going to cover is cross-validation, hyperparameter tuning, And then after doing both of them, I'll be going into deep learning. So when if you do this kind of small little projects and follow the structure right now, right, you will have already have a rock solid foundation when we go to hyperparameter tuning and deep learning. And Monish, what to do after I do the project? After doing the project, you upload it to your GitHub. Go to github.com. There is also a wonderful website called Hugging Face, which I'm going to introduce to you later. Go to your GitHub. In your GitHub, in your repository, click on new, and here give any repository name like the project that you have done, like Titanic Survivability ML, something like that, and keep it as public, and just click on create repository. After clicking on create repository, you will get the steps. You'll get the steps to follow. Do the steps one by one in terminal, and you'll be able to upload your project to GitHub. Try this in the weekdays, any time when you have some time. And if you are not able to upload it to GitHub, and if you are feeling any difficulty when uploading it to GitHub, please message me. I will send you the resources, or I will myself connect with you, and we will upload it to your GitHub. It's a very simple thing. You just give the repository name, click on create repository, and automatically the steps will be shown. Just copy each command and put it in your terminal. It will work. Or you can just drag and drop the project.
There is an option, I think Colab already has an option that where you can push your IPNB file to the GitHub.
Oh, but
I think it's under file. So you can push your...
awesome. Yeah, save a copy in GitHub. Yeah, you can also try this. Thank you, Kom. I should not see this till now.
No, I just did it, so I was like,
Okay.
I didn't know. I went through the roundabout step and figured this out.
So yeah, thank you, Komla. Yeah, you can all do this then. I think this is more simple. Just click on save a copy in GitHub, and a copy will be saved in your GitHub. That works. This is just to showcase your work to the world. Yeah, am I missing anything? Yeah. So amazing work today. Thanks for coding along. That is all I have. If anyone have any doubts, please do let me know. And I think you already have this link. If not, please let me know. I'll send the recording of this class and the presentation in the group. Yeah, any doubts on anything? Yeah, okay then. I'll give you some time back to you. Love you all then. Take care. See you all in the next class.
Thank you.
Bye, Linda. Thank you. Thank you. Bye.